Alright guys, so I just want to work through pages 67 and 68 for the homework. I'm also going to post the answer key in case you are wanted to double check. So let's jump right in. So the first example, describe the relationship shown in each table. Is the relationship a function? Explain. The one that they give you here is that the input identifies the hour and the output gives you the cost. The relationship is a function because there is only one output for every input, and that is your definition of a function. For one output, there is only one input. So we can tell that that is a function. The second table, this is also a function because the input identifies the week and the output gives a growth for each week. The relationship is a function because, again, there is only one output for each input. One out for each input. Number one, can you represent either of these functions in the example problem with the equation? So let's go with example A. My rate of change from hour 1 to hour 2, for every 1 hour I'm adding $3. 2 to 3, I add an hour, I add another $3, and it looks like it holds true as every hour I add $3 to the total cost. So this is a function. So for the total cost for this is example 1, cost is equal to my rate of change is $3 for every hour. So the total cost is $3 per hour. So example 2, table B. So let me put table A here.
Heather Brown, could you please call the office?
Table B, I look like for every week gained, I lose 3/4 of growth. But then here, going up a week, I lose 1 1/4. And then here it looks like it stays the same, and then it loses like another quarter. So that one, although this table B is a function, this is, but it doesn't have, but does not have a constant rate of change. So I cannot write it as an equation. So table A, the total cost is equal to $3 an hour. Table B, it is a function, but it doesn't have a constant rate of change, so I cannot write it as using an equation. Suppose you reverse for the inputs and outputs for table B. Would this relationship be a function? So let's just model this real quick. So if I reverse it, I'm going to go over here to the side here. Let's say instead of 1, 4, I go 4, 1, so this is now in and out. 3.25 is 2, 2, 3, 2, 4. Probably something's already going off, like hey, right here. So if I reverse the inputs, and it's the same idea of me going to 2 different barbecue restaurants at the same time, not possible. So would this be a function? No, because input of 2 has 2 different outputs, and it breaks the rule of a function. So that doesn't work. So no, it doesn't work. So no, it is not a function if I reverse it. The table shows the number of concert tickets sold by the 5 students. Is this a function? So here are 5 students. Student 1, 12 tickets. Student 2, 18 tickets. Student 3, 12 tickets. Student 4, 22 tickets. Student 5, 16 tickets. Going back to the function, here's the vocabulary word on the side. For every output, there are no repeated inputs. For every output, there is no repeated or different. For every output, there's only one input for each. So in this case, you may question this one. You're like, hey, Ms. Wynn, right there, that fails as a, there's two outputs with two different inputs. So let's go back to what we talked about in class. Let's talk about going to a barbecue restaurant. So I'm going to do a vertical table here. So I get one, let's say day 1, I go to my favorite restaurant. Day 3, I go to my favorite restaurant. That is totally okay. So therefore, this is a function because it still fits the fact that for every output, there's only one specific input. The outputs can repeat, but the inputs cannot repeat with different outputs. So this is a function. Next one. Use the following situations to solve problems 4 and 5. The table shows the number of calories in different numbers of servings of blueberries. So if I have 1 serving of blueberries, I have 21 calories. 2 servings of blueberries, I have 42 calories. 3 servings of blueberry, I have 63. 4, 84, 5, 105. On the blank graph to the right, add a title and then label and number the axes. And then plot the order pairs. So kind of like what we practiced in class. So this is the title. You could name it as calories from blueberries. I know that my servings are going up by 1, so for the spacing's sake, I'll just go 1, 2, 3, 4, 5. Even increments skipping there. And then I need to label the calories. It starts off 21, 42, but 42 plus another 21, that goes to 63, plus another 21 is 84, plus another 21, that's 105. So we're going by 21 increments. I really don't like to go by 1s or 5s in this case because the first one is 21. So if I go by 1s or 5s, it actually may make my graph kind of skewed. But since it's going by an even increment, you can actually just go 21, so 0 is right there, and then just go 42. As long as you're going by even increments, and you can actually skip if you want. So let's go 0 to 21, 42, 63, 84, and 105. Because these are all going by even increments of 21, right away you can already know, hey, I can actually write an equation for this because the rate of change is constant. It is 21 calories for every 1 serving of blueberries that is increased. So 1 serving, 21 calories. 2 servings, 42. 3 is 63. 4 is 84, and 5 is 105. And this is actually a pretty proportional relationship because it starts at 0, 0, and it's moving at a constant rate of 21 calories per servings. Okay, so this is number of servings. And then this one is the total calories. Explain whether this relationship is a function. Can you represent the data with an equation? Yes, it is a function because for every output there's only one input. We also talked about in class that you can actually, if you want to, do the vertical line test. So, and it passes that vertical line test. So it is a function. So yes, because there is only one output for every input. I'm just using the vocabulary. You can also say it passes the vertical line test, and the equation is calories is equal to 21 calories per serving. You can actually check your work. If you chose 4 servings, 4 times 21 is 84. 1 times 21 is 21. So there is an equation. So not only is it a function, it has a constant rate of change of 21 calories per serving. Next, number 6, substitute the values into the equation y is equal to x minus 3 to complete the table. Then set whether this equation represents a function. Explain your reasoning. So we're just tabling this out. We're taking each of these input and we are literally inputting them into the table. We take each input value and we subtract 3 from it. So negative 2 Minus 3 is negative 5. Negative 1 minus 3 is negative 4. 0 minus 3 is negative 3. 1 minus 3 is negative 2. And then 2 minus 3 is negative 1. So every time looks like every time I go up 1 on my input, okay, I am also adding 1, so there is a constant rate of change. And my equation is actually output is equal to the input minus 3. That's my rule. So is this a function? Yes. Again, if we were to graph this, you can say it passes the vertical line test, but more importantly, yes, because there is one output for every input. And that's why it is a function. There are no repeated inputs with different outputs. For every output, there is one specific input. Number 7, complete the table to show a relationship that is a function that you haven't used yet. Be sure you can represent your function with an equation. So this one, you're just making it up. So you can go, you know that everything's increasing by 1, so you can do something like start with, let's go with 2. And I'm going to, let's say, add 5 each time. So going up by 1 each time, I'm going to add 5, so 2 plus 5 is 7, 12, 17, 22. I am literally just making this up. And this is a function because my constant rate of change is the same. Describe the relationship between the input and the output values of your function. In this case, yes, it is a function because it has one output for every input. And if you want, you can write an equation for this. An equation would be output is equal to, we got to go back to the initial value of 0. So 2, instead of adding 5, I'm going to move back to when it is at input of 0. We call that the initial value. 2 minus 5 is going to be negative 3. Plus my rate of change each time is 5x, or you can go y is equal to 5x minus 3. Yours may not match mine, but the idea is still the same. Again, we're reviewing what is a function. For every output, there is one input. More specifically, you can have repeated inputs with repeated outputs. So, for example, if you got something like 1, 1, but you have the same input, that means it's the same thing, it's a function. However, not a function, I'll do it in red here. This is not a function. Is, for example, you have input 1, 2, input 1, 3. That is not a function. I cannot go to 2 different restaurants at the same time. All right, I hope that helped, guys. Thanks.